Hello there, Mr. Robertson here, and we've got to do some quick reviews. We've got to do a test this week, so a few of the basics we've got to do right here and right now. We want to start off with how to draw those atoms. Remember, they have protons that are plus, neutrons that are neutral, and they have electrons that are negative. We know that the protons and neutrons are in the middle, and the electrons are on the outside. And we know that the protons and the neutrons have mass. And this has almost no mass. It has a little bit, but we can think for year 7, so no mass. We need that information to be able to draw an atom because, let's take carbon, 6, 12. I need to remember that. Remember, the smallest number is always going to be my proton, and this number is the mass, which is the protons plus the neutrons. Like so. Proton plus neutron. Very good, we think. So we can move on. And taking that carbon back over here, 12, 6. I can put in a nucleus, I can have 6p and 6n. And I know that because here I have, you can see good. 6 is protons, 12 is protons plus neutrons. So 12 equals 6 plus n. Take away 6, take away 6. 6 equals n. Like so, easy peasy. Electrons going outside. I can only have 2 electrons in the first shell, always. Maximum of 2. And then in the next shell on the outside, I can have maximum 4. 2 plus 4 is 6. Protons equals electrons. If it's a neutral atom. If it was an ion, it would be different. But that is true for the basic atoms like so. There we go. And the thing is, we have those 2 types of bonding. We have the ionic bonding and the covalent. Now you remember in class, I described this as being like boyfriend and girlfriend. And I described this as being like BFFs, best friends. Because these have the option of sharing electrons. They both want 1 or 2 extra electrons, so they share electrons, and they are very, very happy. This happens in 2 non-metals. For example, it can happen in H2O, it can happen in CO2, for example. Ionic is when they give or take electrons. And it's 1 metal to non-metal. So it could be, for example, the lithium has 1 extra electron. It gives it away to fluorine. You have lithium fluoride. Those 2 have came together. It's important to know if you can work out not just this here, but also how many of each atom is. For example, lithium and oxygen. Lithium has 1 extra electron. Oxygen has space for 2 electrons. So we need 2 lithium atoms to combine with the 1 oxygen. So it needs a balance because every atom wants a full outside shell. That's the aim. That is what they want. That's what they're looking for. Right. So, above from that, we then, let me check my notes. Different, being more reactive. Okay, so you can have, for example, in group 1, so you have lithium, sodium, potassium, and more. And this is all group 1. In the first column, of the periodic table, on the far side of the periodic table, they're the ones going down. They all have, they're in group 1, so they have one outside electron. What I can say is that they all do the same things, they all do the same reactions, but here the electron gets further and further and further away, meaning those atoms are getting further and further and further away from the nucleus, meaning it's easier to get them away, so these are more reactive. It's the opposite in group 7, because then the closer there is space to the nucleus, the easier they can take things up and the more reactive they can be. Remember group 8 at the very end? Argon, neon. They have a full outer shell. Those atoms there are perfectly happy. Those atoms there don't need any more electrons, so they never react with anything. Final little thing to go through is probably just a tiny bit about the difference between metals and non-metal. Most of the periodic table, all of that on the left-hand side, that's going to be metals. Metals have a few properties. They're shiny, they're great at conducting, and they're mostly solids. Those three things usually define metals. Remember, mercury, quicksilver, that's actually a liquid at room temperature, but all the rest are solids. Most of the non-metals you'll find are actually gases. So there's a big difference there. But those things mean that metals can be very, very useful for conducting both heat and electricity, for reflecting different things, to being very strong. We need to make them stronger sometimes, though. So sometimes you have to have an alloy. So maybe, for example, with steel or bronze. And these have extra elements mixed in. They're not chemically joined together. The carbon is not chemically joined to the iron in steel. But just by having little bits of them there, they make the whole thing stronger. They stop it from rusting, for example, and it makes better quality materials that we can use. So, yes, metals are very good. We have to go into the ground to get ore and rock. Rock with metal. Have to get the ore out the ground and process it so we can get the metals out, and then we can use them. But we want them to last a long time. So steel is usually worth much more than iron. It can be stronger, it can be tougher, it can last longer. Whew. Very quick run through the course. Hopefully it helps, and hopefully it'll be a great assessment this week. Take care.